So hi and hello, welcome to our channel named Algo Exploration. My name is Sami. Before building an algorithm, we have to describe the inputs and output. Here, the input is array of size n, and the output is maximum element and minimum element present in an array. Now, here is my first question to you, that if you have a sorted array and you have to find the maximum and minimum element, in how much time you will find it? So the answer will be order of 1. Why? Because if you have given a sorted array, the minimum element will be always present at the first index and the maximum element will be always present in the last index. So to access the first and last index will be constant, therefore order of 1. Now let's start it by finding the maximum and minimum element without using divide and conquer technique. So to give you guys a hint how to find the maximum and minimum element. Now here is an example. We have this array. Now to find the maximum element, first we have to make max as first element, that is 42. Then we have to compare with this second index element, that is 18, and we have to compare it. Whether if it is greater, then you have to update it, or else not. So it is not greater, so we will increment the I, that will be 76. Now 76 is greater than 42, so we will update it to 76. Then again increment the I, not greater, 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 increment the I, yes it is greater than 76, then update it to 84. Now again increment the I, 33, not greater, increment the I, 96, it is greater, so update. So what will be the pseudocode? Here the maximum element, max variable will have order a of 0, and using the for loop starting with I equals to 1 and going to n I plus plus. If we found out that a of I is greater than max, then we will update the max. That's it. So here the time complexity of this code snippet will be order of n. Now we have to find the number of comparison. Actually, first we are storing this element in max, and then we are comparing with n minus 1 element. So the number of comparison will be n minus 1. Similarly, for finding the minimum element, we have to follow this strategy only. That is, the min is the first element, that is 42 only. Now we have to compare with the second element, that is 18. Whether it is a minimum, then we will update it. Then we have to compare with the next element, that is 76, not smaller, then increment it 9. Yes, it is smaller, and update it. Not smaller, not smaller, not smaller, not smaller, not smaller, not smaller. So what will be the pseudocode here? Min equals to a of 0. Then with the for loop starting with I equals to 1 and going till I is less than n, I plus plus. If we found out that a of I is lesser than min, then we will update the min. And that's it. Here also the time complexity will be order of n, and the number of comparison is n minus 1. Now finding maximum element and the minimum element should be together. So in the code, if we put these two code snippets, the time complexity will be order of n only, but the number of comparison will be n minus 1 plus n minus 1. That will be 2n minus 1 always. Now, and we have use two for loops. So here the criteria is we have to find the maximum and minimum element in one loop. So let's see how we can find it. Let's say the maximum and minimum element is a of 0. Now with the help of the for loop, starting with I equals to 1 going till n, excluding if a of I is greater than max, then we will update the max, or else. Now here many of you guys will make an error that if it is not the case, then they will write min equals to a of I, but actually it is wrong. Why? Because let's take an example. So here the maximum will be 1 and the minimum will be 1 initially. Now let's start comparing by the second index, that is 5. Now is 5 is greater than maximum, that is 1? Yes it is. So we will update the max, that is 5. Now here the I will be at third index, that is 4. So whether 4 is greater than 5? No, it is not. So we will go in else part, and here it says that min equals to a of I, that is 4. Actually it should not happen because the minimum element is 1. So here also we have to compare whether, that is if a of I is less than min or not. If yes, then only we will update the min. Now let's start from here only. Now whether 4 is greater than 5? No, it is not. So we will compare here also whether 4 is less than 1 or not. Also not. So the 1 remain as it is. So we will come here whether this condition 3 is greater than 5? No, it is not. So after that we will come here in else part whether 3 is less than 5, sorry 1, no. So we got the maximum and minimum. So in this way we can find the maximum and minimum element in one loop. Here the time complexity will be order of n. Now let's analyze the number of comparison here. Now we have actually three cases: best case, worst case and average case. Let's find the best case. The best case will be when only if part will execute, such that the condition will always pass. This condition will always get passed, so that it will never get into the else part. So here the best case will be n minus 1, and this will happen only the now let's see the worst case. Here the worst case will happen if we are checking for both the conditions. If this condition fails, then we will check for this condition. So if part n minus 1 comparison, and for else part n minus 1 comparison. So 2n minus 1. Now let's analyze the average case. Average case is nothing but giving the if part and else part equal chances. That is, if number of comparison, total number of comparison are n minus 1, then for if part we will give n minus 1 by 2, and for else part n minus 1 by 2. Now to pass the condition in if part, the number of comparison will be n minus 1 by 2. But to go in the else part, we have to first go in this condition, and then only we can go here. So it will be n minus 1 by 2 plus n minus 1 by 2. So this is actually the else part, and this is the if part. I hope you got why in else part we have these two times. So if we solve this, we got 3 into n minus 1 by 2. That will be 1.5 n minus 1. So in this way, we can find the complexity, you can say the comparison complexity of best case, worst case and average case. Now I know understanding the average case is little tricky, but it is always been a tricky to finding the average case. Now, as I said earlier, in the understanding of divide and conquer strategy, that while building an algorithm that follows divide and conquer technique, we should define the small problem first, also known as a base case in the recursive code context for termination. So here, the small problem will be if the number of elements are 1 or 2. If the number of elements are 1, then the number of comparison will be 0. Due to this, we will return that element itself as minimum element and maximum element to its parent. And if the number of elements are 2, then we will compare these two elements, and the minimum element will be get written as minimum and the maximum element will get written as maximum to its parent. So let's understand now by taking one example. Now this is an array of length 7. Now here, since we are using divide and conquer technique, we have to divide the whole array into sub-array until we reach to a small problem. Now here the dividing will be, if the size of the array is n, then we will divide into two halves, n by 2 and n by 2. So this will be our dividing structure. Now here the structure of the tree will look like this. Now to find the mid index, the formula will be start plus n divided by 2. Here start is nothing but start index and end is nothing but end index. So to find the mid, 0 plus 6 by 2, that will be 3. So we will call 0, 3 and mid plus 1, end, that is 4, 6. Similarly here the mid will be 0 plus 3 by 2. So it will be 1. Now many of you will argue that 0 plus 3 by 2 will be 1.5, but actually we are taking the floor value, so that will be 1. So we will call 0, 1 and 2, 3. Mid plus 1, that is 1 plus 1, 2, and here the mid value will be 4 plus 6 by 2, that will be 5. So 4, 5 and 6, 6. So in this way we will call the function. Now let's see how we are calling it recursively inside the stack. Now let's name this function. This will be the root. This is C1, that is C11, C12, C2, right child of root, C21 and C22. Now initially the root will be, that will call its first child, that is left child, C1. Then the C1 will call C11. Now since it is a small problem, it will execute and return its value to its parent, that is C1, and due to this it will get popped. So let's delete it. Now after that C1 will call its right child, that is C12, and here also, now since it is a small problem, it will get execute and return its value to C1, that is parent, and it will get popped. So let's delete C12 also. Now C1 has both the values from C11 and C12, so it will return its value to root, and this also will get popped. Now root has the value from its left child, so it will call C2. Similarly C2 will call C21, and it is a small problem, so it will return its value and will get popped. Now C2 will call C22, and It is a small problem, so it will return its value and get popped. Now C2 has both the value from C21 and C22, so it will return its value to root and it will get popped, and finally root also will get popped. So in this way calling happens recursively inside the stack. Now here you have to observe that since C11 and C12 are sibling, it will be reside in the same cell. Let's say root, then C1, then C11, and then it will get popped, and C12 will be reside in this cell only. And C1 and C2 are siblings, so C2 will reside in C1 spot. When this get popped, this will also get popped, so in this cell C2 will reside. Similarly, C2 will call C21 and C22, so in this cell only C12 and C22 will reside. Now let's solve the problem. Now the whole array will get divided by 2 until it reach to the small problem. Now at this level all the functions are having a small problem. So this is index 0 and index 1. Now the number of elements are 2, that is a of 0 and a of 1. So since we have 2 elements, it will get compared and the minimum element will get written as minimum and the maximum element will get written as maximum. So let's say we represent minimum as n and maximum as x. So first maximum element will get written and then minimum. So by comparing these two values, we find out that n is 27 and x is 83. So here 83 and 27. Now these two values as maximum and minimum will get written to its parent, and now this function will call its right child, that is this one. So index at 2, 3. So 2, 3 will be this. Now by comparing, we found out that x is 52 and n is 14. Now it will return x and n to its parent child. Now this function has actually 4 values: 2x, let's say x1, x2, and 2n, n1, n2. x1 has 83 and x2 is 52. Now n1 is 27 and n2 is 14. Now within these two there will be a comparison that who is maximum, and within this it will be a comparison that who is minimum. So here we found out that maximum is 83 and minimum is 14. So here in x place the maximum will be 83 and minimum will be 14. Now these values will return to its parent, and now the root will call its right child starting with index 4 and ending with index 6. Now this function will call its left child index at 4 and 5. It is a small problem, so we will compare it. We found out that x is 68 and n is 9, so it will return x and n to its parent, and now this will call its right child. And we found out element at 6th is 36, which is a single element, so it will return 36, 36, because as I said, if the number of elements are 1, then we will not do any comparison, we will simply return itself that element as minimum and a maximum. So now this function has 3 elements. Let's say x1, x2, n1 and n2. Now x1 is 68 and x2 is 36 and n1 is 9 and n2 is 36. Now there will be a comparison between these two elements and between these two elements. Now we found out that maximum of these two elements is 68 and minimum of these two elements is 9. So 69 and 9, and we will return these two values to its parent. Now similarly here also, this function has four values: x1, x2, n1 and n2. Now x1 value is 83 and x2 value is 69 and n1 value is 40 and n2 value is 9. Now there will be comparison between these two elements and these two elements. So here maximum is 83 and minimum is 9. So 83 comma 9. So this will be our result. So here we can see that the maximum is 83 and minimum is 9. So in this way we actually find the maximum and minimum element in a given array using divide and conquer strategy. Now let's see the pseudocode. Now here I have named the function as mm, obviously that is min-max, and then it will accept three parameters: array, start index and end index. Now as I said that we have to define the small problem first. So here the small problem will be if the number of elements is 1 or if it is 2. So let's see what happens if number of elements is 1. It will compare start index equals to end index. If it is, then it will assign a of s as max and min and it will return it. Or if the number of elements are 2, then it will compare is s is equals to e minus 1 or not. If it is, then there will be a comparison between these two elements. If a of s is greater than a of e, then max will be a of s and min will be a of e, or else max will be a of e and min will be a of s and it will return the value. Now this is a small problem. Now what happens if the number of elements are greater than 2? So here we will first find the mid element. The formula for mid will be s plus e divided by 2, and then it will call the function recursively. So mm by passing the three parameters: array, start index and mid index that we got from here, and after that the result getting from this function will be stored in x1 and n1 as maximum and minimum, and after that it will again call the function by passing three parameters: array, mid plus 1 and e, and the value getting from this function will be stored in x2 and n2. Now after that we actually have four values: x1 and x2, n1 and n2. Now there will be a comparison between x1, x2 and n1 and n2. If we found out that x1 is greater than x2, then the max will be x1 or else max will be x2. If n1 is smaller than n2, then the minimum will be n1 or else min will be n2, and we will return max min. In this way we find the max min from a given array. Now let's see which part is divide, combine and conquer. So actually this is a small problem. Which will take order of 1 time because there is no loop. Now this is the divide part. This will also take order of 1 time because it is actually adding and then dividing. That will be constant part. Now this is the conquer part. So it will be 2t n by 2. Now this is the combine part. This will also take order of 1 because of no loop. Now let's find the recurrence relation based on time. So here the recurrence relation will be Tn equals to 2t n by 2 plus order of 1 plus order of 1, time taken for divide and time taken for combine. When n is greater than 2, or else order of 1 if n equals to 1 or 2. Now since this is the constant part, we can replace this by c. So here it will be Tn equals to 2t n by 2 plus c. Now let's find the time complexity. This is actually cost to divide and combine only at first level. That is when t of n is calling t of n by 2 and t of n by 2, then at this level only the cost is c for divide and then combine. The cost for next level, this will be n by 2. The cost for next level will be taken by these two, and so on. So here is a task for you. Find the time complexity using master theorem. But I will show you using substitution method because I have to show you some cost. Now let's say this is the first equation. T of n by 2 equals to 2t n by 2 square plus c. I have simply replaced n with n by 2. So t of n by 2 square will be 2t n by 2 cube plus c. So this will be second equation and this will be third equation. Now substituting this value in this part. So we get t of n by 2 equals to 2t 2 square n by 2 cube plus 2c plus c. Similarly, substituting this value in this part because t of n by 2, t of n by 2. So we get t of n equals to 2 cube t of n by 2 cube plus 2 square c plus 2c plus c. If you do this for k number of time, we get t of n equals to 2 raised to k t of n by 2 raised to k plus 2 raised to k minus 1 into c plus 2 raised to k minus 2 into c and so on till 2 raised to 1 into c plus c. Now this c can be written as 2 raised to 0 plus c. So we will write 2 raised to 0 plus c. Now I will be reversing this part. So we get 2 raised to k t of n by 2 raised to k plus 2 raised to 0 into c plus 2 raised to 1 into c and so on till 2 raised to k minus 1 into c. Now actually we have to eliminate this function. So let's say t of 2 raised to k equals to 1. Why 1? Because of the termination condition. So here the value of k will be log n base 2. Now substituting the value of k in this equation, we get 2 raised to log n base 2 into 1 plus 2 raised to 0 into c plus 2 raised to 1 into c and so on plus 2 raised to log n base 2 minus 1, substituting k value into c. Now the value of this will be n. Pulling the c from this part, we get c into 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 and so on till 2 raised to log n base 2 minus 1. Now this is the GP series. So it will be n plus c into 1 into 2 raised to log n minus 1 upon 2 minus 1. So n plus c into n by 2 minus 1. So the dominant term is n, so it will be order of n. So the time complexity of this pseudocode will be order of n. Now observe here, this is the stack space. This is cost at first level. This is the cost at second level. This is the cost at third level, and so on. And this is the cost at kth level. So thank you.